Complex numbers now is what we're going to continue talking about. It is defined as the set of all the numbers that have the following form: a plus bi. So every number that is complex should be written in that form. So a and b are real numbers, and I is the imaginary unit. And so whenever we write a number in that form, it belongs to the complex numbers, or the set of complex numbers. We call the number a the real part of the number, and b is the imaginary part of the complex number. Some examples of complex numbers are going to be -4 plus 6i, 2i by itself. It would be considered a purely imaginary number, but you can write it as a complex number as 0 plus 2i. Then counting numbers, like the first type of numbers that we ever learned, can also be written as a complex number. It's considered a pure real number, but you can write it as 3 plus 0i. Next, since we consider complex numbers a number, then we should be able to perform a couple operations that traditional numbers do. So when I mean operations, we mean addition, subtraction, multiplication, and division, right? Or something like that. So the same methods are used for what we call binomials. And something that we got to keep in mind all the time is that I squared is equals to -1, period. So whenever we're talking about adding and subtracting complex numbers, think about it this way. We have two complex numbers which are distinct. So if I'm adding one number plus the other, it is the same thing as adding the real components and adding the imaginary components together. If I am doing subtraction, like here's a complex number minus another complex number, all that we have to do is subtract the real parts from each other plus the subtraction of the imaginary parts from each other. So in words, this says to add or subtract the real parts and then add or subtract their imaginary parts, and then expressing the final solution as a complex number. Whatever you get is going to be in the form of a plus bi. Let's do a couple examples here and perform the indicated operation. So we have 5 minus 11i plus 7 plus 4i, and the overall operation here is addition. So let's figure out its solution. We're going to add the real parts together, plus, and then we're going to subtract the imaginary parts. Add the imaginary parts. Okay, so 5 and 7 are the real portions, and then -11 and 4 are going to be the imaginary numbers. So what is 5 plus 7? It's going to be 12 plus, and then what is -11 plus 4? I think it comes out to be -7. And so we get the number 12 minus 7i as the final solution, right? The sum of these two numbers comes out to be 12 minus 7i. In the second problem, we are doing a subtraction. So remember, real part minus real part, and then imaginary part minus the imaginary part. So we have negative 5 minus negative 11 plus, and then we have 1 in front of that I, so 1 minus negative 6. So we have this setup, right? The real number minus the real number, which is what we have here. And I put it in parentheses to not confuse that negative with that negative. And then we have a 1 here minus that negative 6. So 1 minus negative 6. And let's not forget the I. That goes out here. So negative 5 minus negative 11 is the same thing as negative 5 plus 11 plus. This plus in the middle is just to fit the form of the complex number. If it happens to be a negative in here, like it did in the previous example, then this is going to become a negative number. Right, so we'll have 1 plus 6 here. And so here inside of the parentheses, we'll have 6 plus 7i. And so the subtraction of this number minus this number comes out to be 6 plus 7i. The next thing that we're going to talk about is multiplication of complex numbers. And so here it is going to be performed the same way as multiplying polynomials together or binomials, and using the distributive property and the FOIL method. So if you're familiar with either one, then that's going to be good. Now we want to replace any occurrences of I squared with a negative 1, right? That's part of the definition, right? Part of the definition of the imaginary unit. So let's kind of begin with some examples, because there is no other way to explain these problems than by showing an example. So distribution means multiply whatever's outside of the parentheses into whatever's inside in the parentheses, right? So 4i times 3 is going to be 3 times 4 is 12, so 12i. So this is the solution to this. So 12i, and then minus, we got a 4 times the 6, which is 24, and then I times I. Just like you would do with any variable, it becomes I squared, okay? But this is not in the form of a plus bi, right? There is no I squares in that form. So we're going to do 12i minus 24, and then remember, I squared is the same thing as negative 1, so we write that I squared as a negative 1, 12i, and then just remember that this is not like 24 minus 1, this is negative 24 times negative 1, so that's going to become plus 24, and we'll just rearrange things so they fit the complex form of a number. Okay, so let's kind of go through the steps again. 4i is outside of the parentheses, so I'm going to multiply it to everything that's inside of the parentheses that's next to it. And then we get 12i, which is the product of 4i and 3. And then 4i times negative 6i is negative 24i squared. The I squared becomes a negative 1. Then negative 24 times negative 1 becomes positive 24. And we just rearrange the final solution so that it looks like a complex number. That's it. In the second example, we're going to have a little bit more steps, because we have one binomial times another binomial. Right? We got more things to multiply. So here we're going to do FOIL, or double distribution. And so we're going to multiply this number to this, and then that first same number to the outside. So it'll be 8 times negative 3, then it's going to be negative 24, and then 8 times negative 6, so it would be negative 48, and then the I comes with it. Then, since we did those first two, then we're going to multiply this number to this, and this number to the outside. So negative 4i times negative 3 becomes positive 12i, and then negative 4i times negative 6i is going to become 24i squared. And following the same steps as before, any time that we have an I squared, we need to rewrite it as a negative 1, and then just combine like terms. So negative 24, then we have negative 48 and positive 12i become negative 36i plus 24 times a negative 1. So negative 24 minus 36i minus 24, because positive 24 times negative 1. And then combining like terms, we get negative 48 minus 36i to be the final solution, because we want it to look like this: a plus bi, where negative 48 is a, negative 36 is b, and the I is I. Okay? The next thing that we want to talk about is complex conjugates, which is going to lead us into division of complex numbers. So the first thing is to define what is a complex conjugate. And the complex conjugate of a number a plus bi is a minus bi. It's kind of simple in that way. So the only thing that you're changing is the sign in the middle. And the complex conjugate of a minus bi is the same thing as a plus bi. So they're opposites of each other. So the product of complex conjugates will always give us a real number. So if you're multiplying a plus bi times a minus bi, it'll simplify out to a squared plus b squared. And because multiplication is the same regardless of the order, a minus bi times a plus bi is the same thing as a squared plus b squared in both cases. So complex conjugates are used to divide complex numbers. They're going to help us reach the complex form of a plus bi. Okay? The goal of the division procedure is to obtain a real number in the denominator. So keeping that in mind, let's do a couple examples. So here are the directions. Divide and express the result in standard form. So if we haven't said really what standard form is a plus bi. My solution should be in that form. So this is the original problem. 3i divided by 4 plus I. So I'm thinking 3i divided by this number on the bottom. Traditionally, we could think of this in terms of like fractions or decimals, but here we cannot. So that's why we have to come in and multiply by the complex conjugate of the denominator. So I'm going to write the original problem, and I'm going to show you what we're going to do. You're going to use the same beginning problem, or the original problem, and we're going to multiply both top and bottom by the complex conjugate on the denominator. what this is going to do, or what we're attempting to do, is get a real number in the denominator, like we previously stated, but you're multiplying here by a 1. You know, the numerator and the denominator are the same, therefore you're multiplying by 1. And when you multiply by 1, nothing changes. Okay, it's just a very complicated looking 1, if you will. So let's carry on. We'll have 3i times 4 minus I divided by 4 plus I times 4 minus I. Right, we now have a product in the numerator and a product in the denominator, and essentially division is just a bunch of multiplication, in this case at least. So let's do the top. 3i times 4 becomes 12i minus 3 times 1 is 3, I times I squared. And then in the bottom, if you remember, whenever you multiply conjugates, you essentially get the following, right? A number squared plus, well, a squared plus b squared. Okay? This is what we get. And so in the numerator we have 12i minus 3 times negative 1 divided by 16 plus 1, and keep going with the simplification, and this is what we get pretty much, right? Let me flip the numerator or rearrange it so that we can see what I'm about to do. So we're pretty much done, but we just want to separate things so that it fits the standard form of a complex number. So we'll have 3 over 17 plus 12 over 17, and then don't forget the I. Okay, so this is A plus B I. We have reached the final solution, and it is now in standard form. I'll leave this problem for you to do, and it is essentially the same thing as what we just did. You want to divide and express the result in standard form, and you're dividing 5 plus 4i by 4 minus I. The next thing that we want to talk about is finding the principal square root of a negative number. So just like we did at the beginning when we talked about the imaginary unit I, but more in depth, for any positive real number b, the principal square root of a negative number, negative b, is the following. So you have something under the radical, and essentially what happens is that that negative comes out and becomes I. So the square root of a negative number is simply I times the square root of that number. So that being said, let's do an example. So the directions of the problem is to perform the indicated operations and write the results in standard form. Okay? So we're looking for square root of negative 18 minus square root of negative 8. So the first thing that we just talked about is to get those negatives out from under the radical and turn them into an I, right? So we'll have I square root of 18 minus I square root of 8. Now we have to investigate a little and try to figure out if we can simplify square root of 18, and square root of 8. So we can rewrite 18 as a couple different things. 18 times 1, 6 times 3, and if you do that, think about, is there any benefit in representing 18 as a product of these two numbers? Is there a square root of 6 or a square root of 3? The answer is no, right? Well, not at least not a nice number that comes out of it. So how about 2 times 9? Is there square root of 2? No. At least not an integer or a perfect square. But there is a square root of 9, right? So that's good. Let's kind of leave that for now. And the other square root of 8, let's think about it. There are only several factors for 8. 8 and 1, and 2 and 4. So do we have a square root of 2? No, but we do have a square root of 4. So that's a neat. That's good. So the next step will be to take the square root of 9 and pull it out, and take the square root of 4 and pull that out. So square root of 9 is 3, square root of 4 is 2. So we will have the following: 3 times I times the square root of 2 minus 2 times I times the square root of 2. So a couple things here have aligned, and we have 3i square root of 2 minus 2i square root of 2. So in order to perform this subtraction, the root has to be the same and they both have to have an I. So in this case it works out. So I have 3 of a kind minus 2 of the same kind, and the answer, or the final answer, will be 1 of that kind, right? Essentially I square root of 2 will be the answer. The next thing to do will be negative 1 plus the square root of 5 squared. I suggest that you try it yourself and then watch the rest of the video to see how to do it. So how do we do this problem? So negative 1 plus square root of negative 5 squared is the same thing, or the correct way to do it is to rewrite things because of that power 2. It tells me that I have to rewrite it twice. Essentially I'm multiplying that number to itself 2 times. So let's begin. Negative 1 times negative 1 is positive 1. It would be 1 squared or whatever, but just a 1. And then negative 1 times, and we can even take a step back before we do anything and simplify this. Take that negative out, take that negative out. So and this is probably a better way to do it. You want to simplify those roots really before going too deep into the problem. This is going to make it easier. So going back to what we just did, we have a 1 and then we have a negative 1i square root of 5, right? Negative 1 times negative 1 is 1. Negative 1 times this is negative I square root of 5. Then again, I square root of 5 positive times negative 1 is negative I square root of 5. And now the last part is going to be the tricky one, right? You have I square root of 5 times I square root of 5. So plus I times I is I squared, and then the square root of 5 times the square root of 5 is 5. And these two are multiplied. Let's keep on simplifying. So 1 minus, I have 1 of a kind, well, negative 1 of a kind minus another one of it the same kind. Essentially I have 2 of the same kind, so 2I square root of 5. And so this will be negative 1 times 5 becomes negative 5. And I'll just rewrite it so that we can see what's going on. One minus 5 minus 2 square root of 5 is the same thing as negative 4 minus 2I square root of 5. So A plus BI. Okay, that's it for that problem, and I believe that's everything for this video. Thank you for watching.